Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, we'll go over 2022 AMC 10B number 11. So this problem states, all the high schools in a large school district are involved in a fundraiser selling t-shirts. Which of the following choices is logically equivalent to the statement, no school bigger than Euclid High School sold more t-shirts than Euclid High School? Okay, let's think. What is it saying? So it's a logic problem. No school bigger than Euclid High School. Let's say we have Euclid High School here, and there's a school bigger than that. No school bigger than Euclid High School sold more t-shirts than Euclid High School. So there does not exist such a school such that this sold more t-shirts. So if I say Euclid High School sold t-shirts, then this, let's say this school sold T1 t-shirts, then T1 is less than or equal to T. Okay, let's think about all of the answer choices. A, it says all schools smaller than Euclid High School sold fewer t-shirts than Euclid High School. We don't know about any school smaller than Euclid High School, so that's not true. No school that sold more t-shirts than Euclid High School is bigger than Euclid High School. Yeah, that makes sense. If no school sold more t-shirts than Euclid High School, that is bigger than Euclid High School. So if there exists a school that sold more t-shirts, if there is a school, let's say T2, that sold more t-shirts, then that school has to be smaller. So that makes sense. C, all schools bigger than Euclid High School sold fewer t-shirts than Euclid High School. That makes sense. But you have to think fewer. It just says sold more, so we could have this equal case. So it has to be fewer or equal to, which means that we eliminate C. D says all schools that sold fewer t-shirts is smaller than Euclid High School. We don't know about that, because if I could sell fewer t-shirts and be bigger than Euclid High School, correct? Okay, so let's eliminate D. I have answer choice E. All schools smaller than Euclid High School sold more t-shirts. That doesn't say anything. It says all schools smaller than Euclid High School. We just have information that says no school bigger than Euclid High School sold more t-shirts. So all schools smaller than Euclid High School, we practically don't know anything about them. So answer choice E is also eliminated, which means that our answer choice is going to be B for this problem. Okay, let's turn back and look at this statement. So we know if we have a school bigger than Euclid High School, then it implies sold more t-shirts. Then it implies that the school sold less t-shirts than Euclid. Okay, now let's think about this P and Q. Now let's think about what B says. B says no school that sold more t-shirts than Euclid High School is bigger than Euclid High School. So there does not exist a school that sold more t-shirts than Euclid High School that is bigger than Euclid High School. So there does not exist a school such that they sold more t-shirts. So it means sold more t-shirts implies that the school has to be smaller than Euclid High School. Smaller than or equal to. Let's take a look at these two conditions. Bigger than Euclid, smaller or equal to Euclid. That is basically not P, the opposite of P. because if it's not bigger than Euclid High School, then it has to be smaller or equal to Euclid High School. Okay, how about this part? It says less teachers than Euclid. This is more teachers than Euclid. Actually, this is inaccurate. Less or equal. If that is Q, then this is not Q. Thus, we know if P implies Q, then not Q implies not P. Logically, this is an equivalent that these two conditions are logically equivalent, and they're actually called contrapositive. The reason I went that in detail into this is that for a lot of the proof problems, when you study more math, you find out that direct proof, P to Q, is not necessarily easy to do. But proving contrapositive is easier, so you can try to prove the contrapositive and the original claim will be proved. It's kind of like proof by contradiction, but it's instead of contradiction, we use contrapositive. We prove not Q implies not P, then P implies Q is also true. All right, thank you for watching this episode of Investigation. Catch you in the next one. Peace out.